Hey, hi everyone. Good morning. Hi Harsha. Hi Sandrine. Hi Abdi Fita. Hi Bhavesh. Hi Abhay. Hi Achyut. Anbu, Tim, Pallavi, Murali, Krishna. Do you have alternative way of full join? Okay. So I completely forgot about that. Um, let's try to solve that. Okay. So I haven't thought of it. So okay, there is no alternative to full join. Okay, like you do not have any replacement for full join in MySQL as far as I know. But you can do almost the same thing by using other approaches. Like I think you can use left join, right join, union operator, something like that. Okay, yeah, you can put your answer. We'll try to use your answer and see if that works. Okay. Um, okay, so hi Adam, Krishna, Murthy, Dolly. Okay, so nice to see you all. Uh, we'll just wait for a couple of minutes and then we'll start. So in today's class, what I'm going to be doing is I'm going to start with CTE because because we have finished everything before that, and looks like CTE is pretty popular. I keep getting asked about CTE, so we'll try to cover CTE today, and I'll also try to cover self join. We'll try to solve few different queries. Now I think going forward, the queries that we will be looking at may not be that simple. Okay. So we'll try to solve some queries using CTE and self join. Okay. Window functions I'll be taking up from hopefully from next class. Okay. Next session we'll start with window function. Are we working in PostgreSQL only today or are we using multiple databases? Today I will be using PostgreSQL only because everything that I will be covering is going to be the same for every other RDBMS. Okay, so I'll use Postgres. Okay, so I think I'm going to start. We will have assignment for this weekend. Uh, okay, let me see. I'll come up with the assignment once I cover window functions, okay? Because many of my assignments, right, assignment queries that I have, they you need to use a mixture of window functions, CTE, subqueries, all the different type of joins, everything together, okay, including group by and everything. So I want to cover window function hopefully in the next class, and then I will come up with the assignments with which you will be able to solve any type of SQL queries, okay? So I'm just looking at if they have anything without window functions. No, I think maybe this week, as of now, I do not have. If I try to come up with something tomorrow which does not include window function, then I'll try to share it. Or else once I complete window functions, then I'll try to give you some assignments. Okay. Window functions we'll be covering in the next session. I cannot send because it's larger than. Okay, you can put it in the Telegram group. I'll copy it from there. Okay, so I'll take Abdul Fita's query. Hey, did anyone try to solve that full outer join query in MySQL? If there is anyone else who is using MySQL, anyone here? Okay, so in the group, I see we have 50 messages. I have not seen these messages. Okay, I'll move ahead. Okay, so Abdul Fita, the query that you just shared, right, at 7:34. Okay, my time. So I'll just copy that, paste it in PostgreSQL. Okay. Okay, so I think I did not share my screen. Let me share my screen first. Let me know once you're able to see my screen, okay? Okay, so I put check it. Can you do more problems like question 4? We will be doing even more interesting problems than question 4 today itself, okay? Today I have some 5 SQL queries written which may be more interesting, okay? You'll see. Breakfast not yet after this class. Okay, so can you see my screen? Okay, wait. Can you guys see my screen now? Just let me know. So, Abdifita, this is the query that you just shared, right? Okay, in the group. So I have taken that and I have put it. I think this query is too big. I don't think so. I'm sure there are better ways to solve this. This query is too big the for this particular problem. So what was this problem actually? This was the fourth one, is it? Display all the available paintings. This one. So let me open this in a new window. This is your solution. And hey, can I do one thing? I'll try to take this up at the end, okay? Is that fine? Because this one is a concept that I already covered yesterday regarding full auto join and how we can do it in MySQL. I'll try to explain at the end, okay? Maybe the last 5 or 10 minutes, Abdi Fita, sorry, just remind me, okay? Last 10 minutes, I'll try to solve it. I'll keep this tab open here, okay? So we'll solve it at the end because I want to start with something new today, okay? And I will cover this since I already explained the concept yesterday. I don't want to start with yesterday's concept. So I'll start new. Abdifita, that is fine, right? Okay, just remind me at the end, okay, in case I forget. So today I'm going to start with CTE and I'm going to be we'll try to use a different data set. Basically, the data set that we used previously, that is the sales order data set, okay? So you guys must already be having this data set. And I think we have three tables in this data set. So we have sales order, we have customers, we have products. Okay. So I think these three data set, customers and sales order. Okay. So what I'm going to be starting today is okay. So something called as with clause with with clause in SQL, also referred to as CTE. Okay, so I think this stands for Common Table Expression. Okay. Now, can anyone tell me in simplest of terms, from your own understanding, what exactly is this with clause? What does it do? Anyone? Is this create temp table in Meom? A saved query, create table, temp table, which can be reused. We create a temp table, kind of prefix, another filter condition. Anyone else? A better answer? Temp table, not stored in DB. Okay. Temp table that only exists during the SQL execution, like a variable table to refer easily, temp table to increase performance and reduce query size. Okay, so I see subquery you can use over and okay. So I think this answer subquery. Okay, you can you can consider with clause most closely like a subquery. Okay, so let me tell you now. Generally, where I think this with clause was introduced much later in SQL. I think um, I don't know, maybe 5 or 10 years back. In previously in the initial versions of SQL, we did not have with clause. Okay, and SQL statement would always start from a select clause. Okay, all the queries that we have written, we have seen that it always started with a select clause. Okay, but after with clause was introduced, now we can write SQL queries where the first command does not have to be the select clause, but we can start a select query using a with clause. Okay. Now, what a with clause basically does is whenever you're writing SQL query, if you have some subquery, okay, then you can put that subquery inside a with clause. The advantage is that you can then reuse that subquery multiple times without asking SQL to execute it again. Okay, so let's say you have written a query and there is a subquery. Let's say you have some requirement where you need to do some calculation. Let's say finding the average sales. Okay, and that average sales you are using, let's say, in 5 different places in your query. Okay, for some purpose, what you can do is, instead of putting this subquery in 5 different places, in that case what happens is SQL has to execute it 5 different times, right? Rather, instead of putting it into a subquery, you can put that entire finding the average sales into a with clause, and then you can use that with clause all these 5 times. Okay, what happens is SQL is going to execute your with clause only once. Okay, so this way with clause will not only improve the performance, it will also like make your query more cleaner. Okay, it becomes it becomes very easy to maintain, and it becomes more readable. Okay, of course this is all theory that I'm explaining you. Once we start solving problems, you will better understand this. Okay, so let's understand with clause with a proper example. So let's say I have a question here, something like this. Okay. So I will execute the sales order table. This is my sales order table. It has around 2,800 records. Okay. Now I have a requirement where I have been told find the most profitable orders. Okay. I need to find the most profitable orders. Okay. And they have told most profitable orders are those whose sale price exceeded the average sale price for each city. Okay, and whose deal size was not small. Okay, is the question clear for everyone? um, okay, I hope the question is clear. Now let's try to solve it. So there are a few different things that we need to do, right? I need to find the most profitable orders. So basically, they have told us to display some orders. So they are not told what exactly I need to display. Imagine that I need to display every record from my orders table. Okay, but I only need to display those orders who are considered to be profitable. Okay, and how is an order considered to be profitable? They have already given us the definition. They have told an order is considered to be profitable only if it exceeds the average sale price for each city. Okay, so what this means is, just from reading this second statement, I can tell that first and foremost I need to find the average sale price for each city. Okay, so how do I find the average sale price for each city, right? That's the first thing. So let's try to break this problem into few different parts. First of all, I'm going to find the average sale price for each city. Once I find the average sale price, then I will try to compare that average sale price with my main query. Okay, so in order to find the average sale price, first of all, I need to find the average sale price for each city. If I go into my sales order table, that is this one, I have the sale column here. This is basically my sale price, but I don't see I have a city here. I don't have any column here mentioning which city this order belong to, right? But then I have a customer column here, that is this one. And if I go into my customers table, I can see for each customer which city they belong to is mentioned here. So from this, I can understand that I will need to join the customers table with the sales orders table so that I can try to find the average sales for each city, right? So my first thing that I need to do is select from, okay, and here I need to say sales order. I'll give alias like yes. I need to join with the customers table C on C dot customer ID equal to yes dot customer. Okay, and here let's say I'm just going to do a star. Okay, and if I execute this, now I'm getting again the same 2823 records, and this is fine, right? I have now used the two tables that I need, because I can fetch the city from customers table and I can fetch the sales price from the sales order table. But what I need to do is I need to find the average sales for each city. How can I do that? Anyone? Okay, so Adam already gives the solution for that. And how I can do that is, I know that I need city, okay, and I need the average of sales, right? So average of sales, and let's say this is going to be my average sales, okay. and I need to do a group by here because I'm going to group the data together for each city, and then from each city I'm finding the average sales, right? So I'll do a group by based on city. And now if I execute this, now you can see I'm getting 73 records. Looks like there are 73 cities in our database. Okay. And for each of this city, I'm getting the average sales. Okay. And there are a lot of decimal points here. I don't bother about them as of now because I only need this average sales so that I can do the comparison for each order later on, right? Now, this is one part of the query that I have written. I have found the average sales for each city. Okay. The second thing that I need to do is I need to use this value for each city in my main sales order table and then try to filter the data wherever the sales order is greater than this average sales but corresponding to each city. Okay, that's the important thing. Okay, now there are many different ways of solving this problem. One of the way of solving this problem is by using a with clause. Okay, now I told you what is a with clause. With clause is basically something that can hold a subquery, right? Now this is actually a subquery for me. Okay, this is at this moment it's not a subquery, but I will need to make this into a subquery because my outer query needs to do this comparison for each order, right? So what I'm going to be doing is I'm going to move this entire query inside my with clause. Okay, so how I can move this into with clause is I just say with. Okay, then I give a name for my subquery. Okay, so I will just call it like CTE for now. Okay, and then I'm just going to use the as clause and I'll move this to the right. Okay. Okay. I move this to the right like this. And then here I can just say select star from CTE. Okay. Now, this is basically the syntax of how to use a with clause. You need to have some SQL statement. Okay. And within the parenthesis, and this should be your basically command when you're using a with clause. So you need to use the with clause. Okay. That is the with command here. Then you need to give any name. Then this name CT or whatever, it is up to you. It's always better to give meaningful name. This name should represent what this data is about. Generally, in this particular case, I think this would make more sense if I just use average sales, right? So average sales, I can call it like per city. Okay, this would be more meaningful. So this entire subquery, or sometimes we call it like a temp table. Okay, is I'm going to be referring to them like average sales per city. Okay, and you need to use the as clause. Okay, and then here this is where I'm writing my outer query. Okay, now I'm just doing select star from whatever name I have given here, so that is this one. If I execute this, I'm going to still get the same output. So whether I execute this query here or I execute this entire query here, it's basically going to return the same output. The reason is when I'm doing select star from this internally, SQL, how SQL is going to process this query is, okay, so first of all, SQL is going to execute this. Of course, it's going to first check for the syntax, if all the table name, column names, everything is fine. If everything is fine, then it's going to start processing this query. Okay, when it's going to process this query, it's going to realize that, okay, there is a with clause, right? So with clause, it's going to take this whatever name that you have given. Okay, and then it's going to execute this query. The first thing it's going to do is whatever you have mentioned inside your with clause, that query gets executed, and that query's data will get temporarily stored in the database. And that data, whatever the result set is returned from this particular query, can be referred by using this particular name that you have given. Okay, so this data is temporarily stored in the database, and it is going to be stored until the execution of the query. As soon as the query execution is completed, whatever data was stored from this with clause will be removed from the data, from the memory. Okay, and that is why sometimes we refer to it like temp table. Okay, it's actually not a real temp table because in SQL we have the concept of temp table that has a different meaning. Okay, that is a real temp table. This is something like something similar to a temp table, but this temp table will exist only until the execution of the query. Okay, and it can be referred by this name. Okay, and I'm just using this name to refer to that particular result set, and I'm just saying select star from that result set that you have temporarily stored in your memory. Okay, so this is the syntax of with clause. Okay, I hope this is clear. Now let's come back to our problem. I have found the average sales for each city, but this is not what I want. I want to find the most profitable orders. Most profitable orders are those orders whose sales price exceeds the price that I'm getting here for each city, right? So what I need to do now here is I can just tell I can use this average this table, but I'll just move this or I'll just keep it away for now. Here, the first table that I will need to use is sales orders, because in order to find the sales most profitable orders, I need to basically compare this value with each sales amount, right? So I will tell sales order. I'll give alias like yes. I'll join it with again customer table, because I need to do this comparison for each city, right? So I need the city. So I'll use the customers table. I'm going to join the customer and sales table again using the same join condition, that is c dot customer id equal to s dot customer id. Okay, that's fine. Now comes the important part. Okay, now I need to filter the data. So if I execute only this much, okay, if I execute this much, customers. Okay, so if I execute this much without including the with clause, it works fine, and this is returning me all the sales which along with the customer's data. Okay, what I need to do is I only need to include those sales order. That is, I need to say yes dot sales is greater than. I need to say it is greater than this particular thing. Okay, dot average sales. Okay, I need to do something like this. So whatever average sales that I have got here, I need to mention it here, and I have to check uh, if the sales from the sales order table is greater than this average sales. Okay, but when I'm doing this, I also need to do a comparison with the city, right? So meaning that I will need to use this table, this temp table, that is, or we can call it like temp table or this with clause, okay, or whatever. So I need to use this particular table, right? So first of all, in order to use this, I will need to include it in my from clause. Without mentioning this in my from clause, I will not be able to do this comparison, right? So first of all, what I need to do is I'm going to say join with this particular temp table here, and I'm going to call it like, let's say, average. Okay, something like av. Okay, and how do I join this? So I can join this only by one column, that is city, because this temp table that I have created is having all the data corresponding to each city. So what I can say is av dot city is equal to c dot city. Okay, so with this join, what I'll make sure is every average sales that I have taken is corresponding to the city that the SQL is currently executing, right? And then I can say this one, that is AV dot average sales. So my S dot sales is greater than AV dot average sales. Okay. Hopefully with this, I will be able to get my output. That is, I will be able to fetch all those orders whose sales are greater than the average sales. If I execute this, I am getting 1180 records, but there is one more additional check that I need to do. That is, profitable orders are those whose sales price exceeds the average sales price and whose deal size was not small. Okay. In the sales order table, we have something called as a deal size. They're asking us to not consider the small deal size, right? So I can put another filter condition telling here, mentioning here like yes dot deal size is not equal to small. Okay. And now if I execute this, I'm getting 1175. I think this is the correct number of records. Okay. So let me explain this query once again. Okay. And then I will see if you have any questions. So what am I doing here? Okay. I'm using a with clause here. And inside this with clause, I have basically written a query. This query is going to return me the average sales for each city. Okay. That's it. Okay. It's pretty simple. Join with sales order and customer. I'm doing a simple group by to find the average. The only uh, the only major thing that I'm doing is this query, I'm putting it inside the with clause. So this with clause can be referred by this name that I have given. Okay. And then in this particular case, this kind of becomes my outer query. Okay. Or my main query. And in this outer query, I'm again joining the sales with customers table. Okay. Because I need to filter out the orders who are having sales greater than the average sales corresponding to each city, right? And that is why I need city and the sales amount. So I'm joining these two tables. And then I need, in order to find the average sales, I will need to use this query, and this query can be referred by this name, and that is what I have mentioned here. So this is actually not a real database table. This is just a temp table that I have created using a with clause. Okay, and I'm giving an alias for that here, and I'm joining this table with my customers table using city. Okay, and then finally I'm adding my main filter condition. This is the two main filter condition that was given here. The first thing is I need to only fetch those orders whose sales amount is greater than the average sales amount. That's the first filter condition. And the second filter condition is whose deal size is not equal to small, right? So after all of this, when I execute this, I'm getting 1175 records. Okay, and this is what, so I can also say yes dot star, so I only print the sales order. Okay, and this is exactly what I wanted from this particular query. Okay, is this clear? Any questions about this? Okay, I always tell you we can solve the problem in multiple different ways. I can solve this problem in another way. Okay, like what Suraya is telling here. Instead of using with clause, why couldn't I just use a subquery? I can use a subquery. Okay, and I will show you that method a little after this. But before I use show you the result using subquery, uh, has everyone understood this? Okay, and I'll do one thing. This same problem can be solved without using a with clause, and it can be solved just by using a subquery. Is there anyone here who can solve this problem with using by using subquery? Can you share your solution? Okay, I'll give you 2 minutes. Uh, can anyone solve this? The same problem without using with clause, you can solve it using subquery. Can anyone share your solution? If anyone can share your solution, share it with me. I'll give you 2 minutes, and in that 2 minutes, if anyone has question about with clause, you can ask me. You can solve it using subquery. Let's see if anyone here is able to solve it and share with me the solution. If anyone is not able to solve it, I will solve it, but let's see if anyone here can solve it. Can you use can you use with clause in different query? Can you use with clause in what does that mean? I did not understand. Can you please paste it in chat? Okay. In query replace average sales. Main query replace average sales with that. Okay, so now I'm going to ask you. Most of I think someone Achyut mentioned here. Okay, in with clause, the main clause selected the same table, so we can replace with the condition. Okay, so I think most of you guys would be thinking here is that what we can do is most of you guys are thinking this same query, I can just take it and put it here. Okay, and I can just replace this one. So this entire subquery, I can just remove that. Okay, and I can put it here. Is this what most of you guys are thinking? Okay, and I don't need the with clause here. I'll remove this. Okay, is this what you're thinking? So whatever query that I mentioned in my with clause, I removed it from the with clause and I put it here where I was actually doing the comparison with sales. Okay, do you think this will work? Okay, first of all, here I have two columns, so I cannot have two columns. So I only need to have one column. So I will need to remove this, right? Average sales. Okay. Do you think this will work? Anyone? Do you think this query will return the same output as my above query? Or do you think it's going to have any problem? No. So this query will not will work or not work as per our requirement. Let me also see. Okay, will it work or not? So I have sales order this group by this. Okay. Okay. So First of all, will it throw error or will it not throw an error? Okay, you answer me that. Is this going to throw an error or not? Error, error, no error, throw error. Okay. In my opinion, this is going to throw an error. Okay. So let's try to execute this. Okay. And it's throwing an error. Why? Relation average sales does not exist. Oh, okay, okay. So I need to remove this. So first of all, I'll remove this. Okay. I don't need to use that. Now let's try to run this. Okay. Now also I'm getting an error. You know why I'm getting an error? Because if you see my subquery here, this subquery is returning 73 records because it's an average sales for each city, right? But here I'm having like I'm doing this one, right? This operator, that is the comparison operator. I I will, if I have multiple values on the right hand side, then I have to use either in or not in, right? That greater than or equal to will not work, right? So that's why it's going to throw an error. And even then, but this will not be um, okay. But how can, okay, so I'll still have this one. Okay, how can I make this query work? Okay, there is just one minor change that I think I can do to fix this query. Okay, can anyone tell me what would be that minor change to fix this query? I think, in my opinion, I just need to add one line somewhere and this query will work absolutely fine. Okay, can anyone guess what is that one line that I need to add? Okay, so let's see your answers now. This will tell me how much subquery you have understood. Okay, join to subquery, put this query at the place of joining. In clause, give alias name to subquery intake city. No, okay. There's just one line that I need to add, and I believe the query will work. Okay, and not just the query will work; it will give you the correct data. Group by, no, wrong. Let's see who can answer this correctly. Filter condition. Can you tell me that one line? Okay, whatever that filter condition. Okay, James is telling filter condition city. You are very close, James. Can you give me that line exactly? Just add join in place of where. It will not work, right? If I remove where and put join, it does not work. Uh, Remove the join and add correlated subquery. Again, Rakesh, you are pretty close. Not Rakesh, Harsha, you are pretty close. Okay. Did you guys think how we can solve this? Okay. Let me explain how we can solve it. You need to understand what we are trying to do. Okay. First of all, these three lines here is just returning me all the sales order, right? Every single sales order along with the customer information. I need to filter the sales order, the sales amount, such that it is greater than the average sales for each city. For each city. That is the important thing to remember. Okay. Now, the subquery that I have written here is finding me the average sales for every city. It's finding the average sales for every available city. But I need it to fetch the average sales for one city at a time. If I can somehow modify this query such that it's going to return the average sales for one city at a time and not just any city, it should return the average sales for the city that is currently being processed in my outer query. So when I execute this outer query, the rows will get returned one at a time, right? Internally, it will return one at a time. So when it is getting processed, every row gets processed one at a time, and every time one row is getting processed, there will be some city, right? This every row or every order will belong to some city, right? And that some city will basically be in my customers table. So somehow, if I can take this c dot custom c dot city and join it with this table here, okay, such that whatever city is getting processed in my outer query, I run my subquery only for that particular city, then hopefully I will only get, I will, since I'm doing a group by city, I'll only get one value here, that is the average sales for that particular city, right? And then when I do this comparison, hopefully it should be the correct comparison, right? How I can do that is, here I can just put a where condition here telling that where c dot city equal to, okay, both the alias are same here, so I'll just call it like C2 and this will be S2 and I'll call it like C2. Not the best naming conventions, but just for a quick one. Okay, so I'll just tell C2.city equal to C.city. Okay, this C2.city is from your subquery here, C.city is from your outer query here. Okay, in this case what happens is, when your outer query is getting executed, one each record will basically have one city, right? And that one city I'm filtering it here. So now I cannot run this inner query on its own, because now it has become a correlated subquery, because this query here is dependent on the data returned from the outer query. Okay, one city at a time, right? And then for one city at a time, it's going to find the average sales, and that is what I'm going to do the comparison with, right? And hopefully this should return with the correct record. Now if I execute this, now it is working fine, and you can see it's returning me 1175 records. That is exactly same as what I got here, 1175 records. So this query here is also correct, and this query here is also correct. Okay, but these are two different ways of writing the query. The first query I wrote it using a with clause, okay, and the second query I wrote it using a correlated subquery. Okay, did you understand? This was that one line that I mentioned. Okay, if you just put this one line, everything would work. Okay, so this is what I wanted you guys to tell me. Okay, okay, so if you have to understand this filter condition, you need to understand correlated subquery. Okay, so I will explain this once more, but what about others? Did everyone understand? The time it took to run this query is 4 times. Absolutely correct. That's what I wanted to tell next. Okay, if you see here, I had told you, right? Correlated. Now the biggest difference between correlated subquery and multiple row subquery or scalar subquery is that the multiple row subquery and the scalar subquery will get executed only once, but your correlated subquery will get executed for every single record from your main query. Okay, my main query here is having how many record? 2823 records. So that means this subquery here, this correlated subquery here will get executed 2823 times. Okay, and 2823 times it is going to find the average sales. Okay, so this is actually not a good method because the performance will be slow. Okay, so let's say if I execute this, it's taking 405 milliseconds. Okay, and if I execute the above query here, it's taking 151 milliseconds, so almost three times slower, right? Okay, three times faster, right? This is three times faster, but of course we are only dealing with 2800 record. Imagine if this table was having 1 million record. If it was having 1 million record, then this subquery would get executed 1 million times, and 1 million times it would try to find the average sales. Okay, it's an expensive, because it has to find something, it has to calculate something, right? So this would be very bad for the performance, whereas this would be very fast. Why? Because as soon as you execute this query, SQL will just go ahead and execute this with clause only once. Okay, and everything is temporarily stored in the memory and can be referenced by this name. Okay, so here this subquery gets executed just once. Here this subquery gets executed depending on 2823 times. Okay, so of course whenever you have the possibility to avoid using correlated subquery, always try to avoid it. Okay, so these are the two different ways of solving this problem. Now, to anyone who did not understand, okay, the concept is very simple. Okay, I hope this is pretty simple, you understood this. Okay, and this is one advantage of using with clause. By using with clause, not only your queries will become smaller, it becomes neater, it becomes easy to write and maintain, it also becomes easy to understand. Okay, so but of course in this particular case, the difference between a with clause and this one, you don't see much difference. But when we write a query where there are multiple nested subqueries, using a with clause will be like a lifesaver. Okay, so let me explain this correlated subquery one more time, because I believe few people would still have the confusion. Okay, what am I doing here? Okay, as per my question, I need to only find those sales, those sales order who are having the who are having sales amount greater than the average sales amount corresponding to each city. That each city is the most important thing here. Okay, so imagine if your question was something like, let's say you have another question here and they told you that Okay? Find the most profitable orders, and most profitable orders are those sales order that exceeded the average sales price. Okay, and let's say they removed this particular statement. Okay, so they removed that for each city. Okay, if I had to do this, so let's say I'm going to call it like 1A, okay, or 1B, okay, whatever. Um, in this case, how can I write this query? So the same query, I can just copy it here, okay, and I can paste it. Then you need scalar subquery. Okay, perfect. So then we need scalar subquery, because you see here most profitable orders are those whose sales price is exceeding the average sales price. So I just need to do a comparison with the average sales price. If I had to find the average sales price from the sales order table, then I could just run this much, right? If I just run this, I will get the average sales price from the orders table. So I don't need to join with the customers table, because I'm not bothered about the city. I don't need to do a group by with the city itself, right? So in this case, my subquery kind of becomes the scalar subquery, because I'm trying to find a total average of the sales order. Okay, and then I can just do a total, compare each sales amount with this average sales. Any sales amount that is greater than this average sales, I will fetch it. So if I run this, now I'm getting the output. I'm getting 1168 records. So these are the 1168 orders whose sales amount is greater than the average sales amount. Okay, did you understand the difference here? The question is almost the same. I just removed this particular check telling that for each city. Here, I need to find the average sales without, irrespective of the city. Okay, since it was irrespective of the city, I found the average sales for the entire table, and then I did the simple comparison. This query is very simple, right? Nothing too complex. Okay, but the same kind of question, just by adding one word here, that is city. Just by telling that you need to find the average sales per city, I needed to do my query completely changed. Okay, what is the difference here? Here I found the average sales for the entire table, but here I had to find the average sales for each city. That is why I did a group by city, and then each city, because when I'm doing this comparison, if I did not put this where city equal to city, then I would get average sales for every city at once. I don't want that. I want to find the average sales for one city at a time, right? The city to which this the order of this main query is currently processing, right? And that is why I needed to do all of this, convert that scalar subquery into a subquery, into a correlated subquery, and I need to relate these outer query with the subquery using the city column. Okay, and then I need to fetch the average sales, and then I need to compare that average sales with my main sales from the orders table. Okay, so this is the difference. Okay, this is like, I will call it like 1B alternate question. Okay, so I hope this is clear. If it is not clear, try to watch the recording again. Try to solve this problem on your own. Hopefully you will better understand it then. Okay, okay, fine. So let's move on to the next one. Okay, I hope you got some understanding. If it is confusing, hopefully with the next few problems that we will solve, you will better understand this. Let's go to the next one. The next question that I have is something like this. Okay, and okay, so find the difference in average sales for each month of 2003 and 2004. Okay, can anyone solve this problem? Anyone can tell me what would be the different, what method I can use to solve this problem in simple words? Which clause is supported in every RDBMS? Can anyone solve this problem? I'll execute the sales order table. Okay, and I need to find the difference in average sales for each month of 2003 and 2004, right? So the very first thing when I look at this question is, I can say that, okay, I'm only interested in the average sales, but I'm interested in the difference in average sales, okay, for each month and for these 2 years. So looks like I need to consider the data for two different years, okay, 2003 and 2004, okay, and for each of these years, I need to find the average sales corresponding to each month each of these years is going to have months like Jan to December, right? So I need to find what is the average sales in Jan of 2003. Okay, then I need to compare that value with the average sales in Jan of 2004. Okay, so average sales in Jan of 2003, compare it with average sales with Jan of 2004, and then do the same for every other month, so Feb, March until December. Okay, and then display your result. Okay, how can I do this? Anyone has any idea what concept can we use? How do we do this? Anyone? No, no one has any idea. Am I in the wrong tab? Okay, no idea here. So no problem. Let's try to solve it step by step. Okay. So the very first thing is I need to find average sales. So average sales is only present in one of my table. I know that, and that is sales order, right? So this is fine. Okay. And I'm going to call it like, let's say I'll call it like yes. Okay. What do I need? I need to find the average sales for each month of 2003, 2004. So let's do one thing. I'm first going to find the average sales for 1 year at a time. So first, let me try to find the average sales for the year 2003. So I'm just going to put a filter here telling that where year ID equal to 2003. Okay. So if I do this and if I execute this, I'll get all the sales order only for 2003, right? Next thing what I need to do is I need to find the average sales, but I need to find the average sales for each month, because you can see here there may be some orders, there may be multiple orders in the same month, right? So I need to group the data based on each month, right? How do I group the data based on each month? So I can just tell group by, and month I can either take it from the month ID here, but then I will get this number. I would prefer to have the month value like Jan, Feb or something. So what I'll do is I'll use a function called as toChar here, and I'll fetch that toChar of month from the order date field. So order date, and here I will say Gamboyan. Okay, so I'll group by this. I'll do this. Okay. And if I execute this, now you can see I'm getting 12 records. Okay. So just 12 records. Why? I fetched from the sales order table, I fetched all the data for 2003. Okay. And then I want to find the average sales, right? So first of all, I need to group the data for each month. Okay. So I group the data for each month by fetching the month from the order date field. And then I need to find the average sales. So I can just tell average of sales, and this is going to be my average sales, right? So if I execute this, now you can see I'm getting 12 records, and this is basically giving me the average sales for each month, and this belongs to the year 2003. So here I can just tell year ID. Okay, and just to make it more clear, now if I run this, I'm getting an error here, and let's say I'll put this, either I can put that here in the group by. It's not going to make any difference in this particular case. Why? Because I know that in this query there is only 1 year. So whether I if I put that group by here, it's still going to be the same. So now you can see I'm getting 12 records. All this belongs to the year 2003, and for all the 12 different months, and its average sales is given here. Okay. So what this means is I have found, first part of my query, I have found for 2003 for each month what was the average sales. I have got it from this query. Is this fine? I hope this is clear, right? Now I need to write another query for 2004. So I'll again copy the same thing. I'll write the almost the same query for 2004. So I'll change this to 2004, and I think that's all. Then everything else is the same. So now if I execute this, this is going to fetch me the average sales for each month for the year 2004. So I have got this, right? So I have got the data for 2003. I have got the data for 2004. Now I just need to write a main query where I'll do the comparison. So what I can do is I can put this inside a with clause. I can put this inside another with clause, and then I can write a main query where I compare these two with clause results. Okay. So what I can just do is I can just say with um, year 2003 as, okay, and I'll move this to the right. I'll just enclose this inside the inside the parenthesis. I'll put a comma because I need another with clause here, right? So when you want to put multiple subqueries or temp tables in a with clause, you can just do it like this. This is the syntax. So I can just tell year underscore 2004 as, okay, and this whole thing here. Okay, so this is the syntax. Okay, and then here I can just tell select star from whatever with. So let's say if I just do this one, okay, and that will work. So when you want to include multiple temp tables in your with clause, you don't need to use the with clause multiple times. Just mention it once, and then here you can just give a name for your with clause, mention your query, put a comma here, then mention the name for the second query here, then put the second query here. Okay, and then always you need to have a main query here. Okay, and the main query you can basically refer both these temp tables. Okay, so here I'm only referring 2003. If I execute this, it's only going to fetch me the data from 2003. Okay, so when I execute this query, SQL will come to know that there are two with clauses, and so inside this with clause, inside your main query, you're only fetching the data from one of the with clause. So only the data from this, whatever was saved for this particular temp table, will get returned. Okay, so I hope this is clear. Uh, what if some values have month? Okay, if there are null values, let's try to solve that a little later. Okay, so let's see how to handle null values. Okay, so generally if you have null values, I can just put a function call is here, and if it is null, I can try to convert that uh, null into a zero so that the average will not fail. Okay, if I did not handle that, if there are null values, I think this average would throw an error. Okay, because average will expect that every value present in sales is an integer. Okay, if there is anything other than integer, then it's going to throw an error, and null is not an integer. Okay, okay, so now I have got the data for 2003. I have got the average sales for each month for 2003, and I have got the average sales for each month for 2004. Now I need to do a comparison. So in order to do the comparison, I will need to fetch the data from both these tables. So this one I'm just going to call it like y03. Okay, I'll join it with my 2004 table. Okay, so this will be 2004. I'll call it like y04, that is year 04. Okay, how can I do the join? Okay, can you tell me on which columns should I do the join? Using month? Why not year? I can I consider both month and year? Year ID? Both? Are you sure? Should I consider both year and month, or should I only consider month? Just month. I cannot consider both year and month, right? Because imagine if I consider year. Here the year is 2003, here the year is 2004. If I join based on year, it will never join. It will basically never match. I will always get zero records. Okay. For example, let's say I do y03 dot year ID equal to y04 dot year ID. Okay. And I'll copy this and I'll say and with the month. Where is the month? Okay, so I'll give an alias here. So I'll call it like as month. Okay, I'll just call it like MON. Okay, MON, and here also I'll call it like MON. Okay, and I'll say MON. Okay, now if I execute this, it's going to return me zero records. Why? Because the year ID in Y03 is 2003, and I'm trying to tell 2003 equal to 2004. It is never going to match, so always it is going to return zero records. So I should not be considering the year column. So remember, just because you have some columns in your multiple tables and they have the same what same column name and looks like the data is also similar, you should always, whenever you're using a join condition, make sure it satisfies your requirement. Okay, in this case I don't need to do a join based on this because I only need to compare between months, right? I need to compare Jan of 2003 with Jan of 2004 and so on and so forth, right? So I only need to consider month. And now if I execute this, now you can see I'm still getting 12 records. So here you can see I'm getting for 2003 for the months the average, and here the 2004 for the each month the average. Okay, now this looks like the correct data, right? Now I need to find a difference. How do I find a difference? So first of all, I'm not bothered whether it is which year. I am only bothered about the month. So what I can just tell is I'll say y03 dot month. Okay, and then I need to find the average, right? That is the difference, right? So I can just tell y03 dot what was that, average sales. Okay, minus y04 dot average sales. Okay, and this whole thing I'll put it inside the parenthesis and I'll call it like difference. Okay, now if I execute this, if I execute this, I'm getting an error. Why? Okay, so it is not month, it is MON. Okay, and if I execute this, now I'm getting month and the difference. But you see, in some of the difference, I'm getting negative values here. Okay, I'm not really interested in fetching the negative values or positive values. I only want to know what was the difference between them, right? In that case, in order to find the absolute value, we have a function called as ABS. Okay, that is basically stands for absolute value. So this will basically return the same value, but it will just ignore the negative sign, okay, or the positive sign. So now if I execute this, now I'm getting the correct output. So this is actually the final output that I needed for my query. So what is this giving? This is giving the difference in the average sales for each month between 2003 and 2004. Okay, so this is how I have solved this particular problem. Okay, did everyone understand this query? Anyone here? Okay, and not just understand this query, but you also understood how with clause was very helpful in this case, right? I could also write this query using multiple subqueries here, but this is more neater, right? I already have the data fetched for 2003, I already have the data fetched for 2004, and then I have this one, right? Now this query is fine, but this is not the best way of solving this problem. There is a better way of solving this problem. Okay, I will tell that in a short while, but any questions on this particular query? uh, how can you solve it using correlated subquery? I don't think so you can solve it using correlated subquery. Okay, so someone asking here, can I run these two? Okay, so now I want to ask you, can I only execute this statement here? Will it work? You guys only think, will it work? It will not work, right? So the answer to your question is straight here. How will it work? Because as soon as I execute only these three lines, first of all, SQL, what is the order of operation? First, it is going to see which table it is, right? In your from clause. In the from clause, I am trying to access YR underscore 2003. SQL has no idea what is YR underscore 2003 if I execute only these three lines, because YR underscore 2003 is not a table in SQL. Only if I execute this entire thing, SQL is first going to see if YR underscore 2003 is a database table. It's not a database table, but I have used a with clause where I have given this name to a temp table. So then SQL will know, okay, this is not a relational table, but this is the data coming from a with clause that is here, which I can execute and get the data from. Okay, so the answer to your question is you cannot execute this. It's going to throw an error. Okay, so now this is fine. I hope everyone understood this particular problem. There is a better way of solving this problem, and a better way of solving this problem is if you look at this query, okay, and you might get asked this kind of question in interviews or when you're working on a project. Your manager might tell you that, hey, we have these queries. I think we can improve this query. Okay, how do you think we can improve this query? What is the biggest problem in this query? Okay, answer me that. What do you think is the biggest problem in this query? Just by looking at it. Okay, so Brent has given the answer, that is use only one with clause, because here I am doing repetition, right? If you see here, I have this query here, okay, and I have this query here. They are almost the same. The only difference is I am fetching it for two different dates, right? So it's like I'm re-executing. I'm basically repeating my queries. Okay, here also I'm using the sales order table. Here also I'm using the sales order table. I'm doing the group by based on the same fields. I'm fetching the select clause also same fields. Just my filter condition is for two different values. Okay, why should I be using two different subqueries in this case? Why can't I just use one subquery and I filter the data for 2003 and 2004 together? I can easily do that, right? So whenever you see a query where you have multiple executions of, where you're basically writing multiple subqueries, that is a clear indication that that query can be improved to reduce the number of subqueries. Okay, the more subqueries you have, the more SQL has to execute it, right? The less execution you give to SQL, the better performance and the better for maintenance as well, right? So the simple answer is we can eliminate two with clauses here and just have one with clause. Okay, but so let's say if I had one with clause where I put year ID in 2003 2004, but how do you do this comparison then? Anyone? If I have just one with clause here, and then if I do this, um, okay, self join, right? There is something called as a self join. Okay, now I will try to give you a solution to this problem a little later, but before I give you a solution for this, okay, so okay, so I'll just mention one comment here. So this is using little solution to using correlated subquery. Okay, and this is solution one using with clause. Okay, and this is fine. This is this one. Okay, here I'll tell this is solution one using with using multiple clause. Okay, temp tables. Okay, now there is another solution for this using self self join. Okay, now the solution using self join, I'll come back a little later, but because before that I want to explain you what self join is, right? So let me explain you self join, but I'm going to explain you self join using an example. Okay, so in order to explain self join, I'm going to use a table, okay, different table. Okay, and that is going to be the employee master table. Okay, so I like this is a different data set. You in your database you try to execute this. So I'm just going to create this table. It's a new table, employee underscore master, and I'm going to insert 5 records into this table. Okay, so I have that a new table to explain self join. Okay, and my table data is something like this. Okay, so imagine that I have a table called as employee master where I have the employee ID, employee name, their salary, and their manager ID. Okay, I have a requirement where I have been told to find the employee and their manager. Okay, so I need to write a query to find the employee and their manager, right? But if you look at in employee master table, I have only one table which has information both for employee and manager. Okay, in some cases you might have a separate table for employee and you might have a separate table for manager, and you can join the two tables together to fetch the data. But in this particular case, there is one table only which has both information about employee and manager. Okay, so in this particular case, one of the ways of solving this problem is using self join. So why self join? Because okay, first of all, what is self join? Whenever you join a table to itself, that is called as a self join. So simple definition. Okay, so self join is when you join a table to itself. Okay, the most simplest definition for self join is when you join a table to itself, that is called as a self join. If you had a separate employee table and a separate manager table, you could join employee table with a manager table. So these are two different tables. This would maybe it would become an inner join, right? In this particular case, I have only one table, employee master. So I need to join employee master with employee master again in order to find a solution. Okay, I'll explain that in a little later. But first of all, my question is, why do I need to join employee master with employee master again? Because you see here I have this employee ID here, right? And if you look at the manager ID, these both kind of looks like the same values. The values are the same, right? So because a manager is also an employee of your company, right? So in this particular case, you can see that John Smith is an employee. Okay, he's having an ID as 1. His manager is having the ID as 3. Okay, so this is the ID 3, and if I look for ID 3 in my employee ID column here, it's Tom Lennon. So what this means is John Smith's manager is Tom Lennon. Okay. Similarly, Jane Anderson, his manager is ID3. ID3 is again Tom Lennon. So Jane Anderson's manager also is Tom Lennon. Okay. Tom Lennon, if you see here, his manager is number 4. Number 4 is Annie Connor. Okay. So Tom Lennon's manager is Annie Connor, right? And Annie Connor, if I see here, she does not have any manager. Looks like maybe she is the CEO or she is the boss. She does not have any manager. Okay. Because it is null here. Okay. And there is no ID corresponding to a manager, right? Then comes to the last employee, that is Jeremy York. Jeremy York has manager. His ID is 1. ID1 belongs to John Smith. So looks like Jeremy York's manager is John Smith. Okay. So we need to write a query where I need to have one column with employee name and another column with the manager name. Okay. How do I do this? Okay. There is no way I could do this by using inner join or left join or right join or etc. Right? Because there's only one table. I do not have another table to join with. And just from one table, how do I do this? Because I need to join the column employee ID with the manager ID such that I can do the proper matching. Okay. Whenever you have this kind of a requirement, we can use self join. So let's see how we can solve this. So first of all, I'm just going to say select from this table. Okay. And I need to give proper alias. Okay. So okay, before that, I'll join with the same table again because why am I joining the same table to itself is because I want SQL to treat the first copy of this table to be something like an employee table. So I'm going to call it like employee table. Okay. And the second copy of the same table to be the manager table. Okay. So I'm telling, hey, SQL, I want you to consider employee master table first time as an employee table and then join with the same table again. That is, you consider the same table again. And this time you consider it like a manager table. Okay. And how do I want to join this table? Okay. So I can just tell. So I have the employee table. I have his ID. If okay, I am not interested in the employee ID. I'm interested in for each employee, I want to find their manager, right? So this employee has the manager here. His manager ID is here. So I can just tell EMP, that is employee table dot manager ID is equal to, okay. So I have the manager ID here. I have another table which is the manager table, and in the manager table also he's going to have some employee ID. Every manager also will have some employee ID, right? So this manager ID's employee ID will be present in this column, right? So I can just tell mng.id, right? So this is, I'm going to each employee, I'm going to fetch their manager ID, and then I'm going to the manager table and manager's employee ID I'm taking, and I'm trying to do a comparison here. Okay. Hopefully this is going to return me the employee and their manager. Okay. So here I am just going to display employee dot name as employee name, and then I'm just going to say mng dot I want to fetch manager name, right? So mng dot name as manager name. Okay. If I execute this, now you can see that it's telling me John Smith's manager is Tom Lennon, Jane Anderson's manager is Tom Lennon, Tom Lennon's manager is Annie Connor, Jeremy York's manager is John Smith. Okay, this is exactly what I wanted, but there is one problem. The problem is, if you look at my employee master table, if I see here, I have 5 employees, right? John and okay, but before that, let me execute this and let me print the data here. Okay, this is what I have. Okay, so okay, this is what I have. So I've got only 4 records. So I have got the this is the employee, this is the manager. So John Smith's manager is Tom Lennon, James Anderson's is Tom Lennon, Tom Lennon's also manager is Annie Connor, and Jeremy York's manager is John Smith. But one of the employee that is missing here is Annie Connor. I have not got the record for Annie Connor. Only 4 records I have got, but in my employee master, I can see there are 5 employees, right? So this Annie Connor, since there is a null in the manager ID, this manager ID here, this join condition failed. Okay, this particular join condition failed here for Annie Connor. So I want to make sure that I fetch every employee. So what I can do is I can just do a left join here. And now if I fetch, I will get all the records. For Annie Connor, I will get the manager as null. okay, because any corner does not have any manager. Okay, so this is how self join works when you join a table to itself. Okay, now I'm 100% sure not everyone has understood this query, because self join is not something that you will understand right away. Okay, so I'll just try to explain it in a more simple way using an Excel file here. Okay, so what I did in this query was I told SQL to consider the same table two different times. Okay, I'm joining the same table two different times. So I'm joining basically same table, but I have given it two different alias. Okay, so this is my employee table and this is my manager table. Okay, whenever you're using a self join, the alias that you give to your table is very important. Okay, remember that. Okay, because your alias, once you give an alias to a table, internally you have to interpret that this is my employee table now and this is my manager table now. You know that this is the same table, but because you have given different alias, you have to now consider when you're trying to solve this problem, you have to internally think that okay, this is my employee table and this is my manager table. My employee table will have a manager ID, so I'm taking his manager ID, and my manager table is going to have an employee ID. Okay, and I'm going to take his employee ID and I'm going to do the comparison, and then I'm going to fetch the result. Okay, so this is what is happening. So when I get John Smith here, okay, it's the employee table. I will take his manager ID here, 3. Okay, his manager ID is 3, right? And from this manager table, I will go and I'll compare it with the manager's employee ID, that is this one, 3. This 3 will match with Tom Lennon. Okay, so this John Smith here, okay, will match with Tom Lennon here. Okay, so this is what will happen. When I go and execute the second record, this one, this manager ID 3 will again match with only this particular record. So Jane Anderson will get matched with Tom Lennon again. Okay, so manager is again the same. When it comes to the third record, Tom Lennon, his manager ID is 4. This 4 will get matched with this one. So remember, I'm comparing this column here, okay, with this column here. Okay, so for the third record, Tom Lennon's manager ID is 4. It will get matched here. That is Annie Connor, right? So Tom Lennon will be here. Annie Connor is what it gets matched with, this one. Next record is Annie Connor. Annie Connor does not have any manager ID. So there is this null is not going to match with any of this record here. So basically nothing will get returned. Okay. So it will then SQL will go into the fifth record, Jeremy York. Jeremy York's manager ID is 1. Okay. So Jeremy York, okay, this one, his manager ID is 1. Manager ID in the manager table, the 1 is the employee ID of John Smith. So John Smith will get returned. Okay, this is what will get returned by inner join. But then since I'm using a left join, it will go into the leftmost table and it will see are there any record that was not returned from the inner join, and that is any corner. It will get returned, and I'm fetching this manager ID from the manager table. But since there is no match, this will be returned as null. Okay, so this is internally how the self join is getting SQL is executing the self join. Okay, is this clear? Did everyone understand? Naveen, if you write like that, you will get wrong output, and you need to think why you will get wrong output. Okay, okay, so everyone understood self join, right? No questions. Okay, now I want to give you a quick assignment here. Okay, now since you have understood the concept of self join, can you solve this query question number 2, that is find the difference in average sales for each month of 2003 2004 using self join? Can you solve it? Anyone? I'll give you 2 minutes. Let's see who can solve it. Okay, I'll just paste the same question, same solution here. You can almost reuse the same query and just do certain modifications to use the self join. Anyone? Can you guys try at least? Okay, anyone who wants to try, you can try. I will try to solve this problem. Okay, and I'll take this. Okay, so what I'm going to do is I will not I'll try to write it here. Okay, so I told you the biggest problem in this query was we basically using the same query multiple times, right? We didn't need to write this query multiple times. We could just write it once, right? So let's see how to do that. So what I'm going to do is I'm just going to copy one of these queries here, okay, and I will paste it here, okay. So I pasted it here, and here year ID I will just tell in 2003 comma 2004, okay. If I execute this, now we can see that I'm getting 24 records. And if I do an order by, so let's say if I do order by 1, okay, and if I execute this, you can see here the first 12 record is for 2003 and next 12 record is for 2004. So I have got the average sales for each month corresponding to these 2 years. That's fine, okay. Now what? Okay, I have got this, but I need to basically compare 2003 September data with 2004 September data. So one record of this result set I need to compare with another record of that same result set. Okay, so one of the way of solving this is by using self join. So first of all, what I'm going to do is I need this data. So I will, okay, this order by maybe I don't need. I will just put this inside a with clause. So I'm just going to say with, and I'm going to call it like, let's say, what do I call it? Maybe I'll just call it like CT. Okay, so I'll just move this to the right. Okay, this one, and here I will just tell select star from CTE. Okay, and I will execute this. Okay, now I'm getting again 24 records, same thing. Okay, now this is fine. So I have I have a table which is having information for both 2003 and information for 2004. What I want to do is I want to create a table which has only information of 2003, and I want to create another table which has only information about 2004, and then I can compare these two tables. So what I'm going to do is I'm going to say CTE, and I'll say this is Y03, okay, and I'm going to join it with CTE again, and I'll call it like Y04. And how do I join these two tables? Okay, uh, before I mention join conditions, let me put a filter condition here. Okay, I want my Y03 to only have data from 2003. So what I can do is I'll say Y03 dot year ID is equal to 2003. Okay, and similarly Y04 dot year ID is equal to 2004. So I have used this CTE table here is having data for both the years, and I have used this table two different times. Once I have given the alias like Y03, the second one I have given the alias like Y04, and then I have made sure that Y03 is only having the data for 2003, Y04 is only having the data for 2004. Okay, that is fine. Now I need to join this. Okay, so I can join this again by using the month ID, because month ID is going to be the same. I should not be joining based on year ID, because year ID is different for both these tables, but month ID is the same. So I can just tell y03.mon equal to y04.mon. Okay, so I think with this the join and everything should work fine. Next, what, okay, let me just print this, and now you can see that from 24 now it's only fetching me 12 records. Why? This table here is only having 12 records. This table is here only having 12 records. And why is it only having 12 records? Because I put the filter condition such that it only fetches data for 2003 or 2004, which only has 12 records each, right? And then from those 12 records, I'm comparing for each month, okay, by using this join condition, right? So I'm getting the 12 records that I wanted. Now, again, the same thing. So I can just tell y03.mon, okay, comma, the same thing, that is here how I'm doing this comparison. So I can just reuse that here. Okay, and now if I execute this, you can see that I'm getting the same output, 12 records and the average sales for each month. Okay, so this query here is returning me 12 records, and this query here is also returning me the same 12 records, and not just the number of records, but data also is the same. Okay, did you guys understand? So solution 1 using multiple with clauses, solution 2 using a single with clause but using a self join. Okay, this is a better approach because we are executing a subquery just once. Okay, any confusion about this? Is it all clear? Insert statement, I will give it another just 5 minutes, 10 minutes for the class. I will share it after this class. Okay, so Shiva has given a query, average sales, case when then sales. Okay, so let's see Shiva's solution if it works. Okay, so this is a solution given by Shiva. Okay, if you guys have any other solution, you let me know. Okay, I'll execute his solution here. Okay, so this one, select this. Um, where is the front class? Average of this. Average of this. This is the difference. This is this one. Okay, so let's see if this works. Syntax error. Uh, okay, maybe number is not allowed. So let's say YR underscore 2003, YR underscore 2004. Okay, this will anyways not work. This will not work, but let's see. Does not exist. So let me comment out this one. Sales order. What is it? Air ID must appear in group by. Okay, so okay, it's group by. Group by this one. Order date must appear. Okay, so I'll do this one. Okay. Okay, so you're getting some data here, but this is not the correct data. It's not fine. Okay, so this solution is wrong. So I'll remove that. If anyone, the same problem can be solved in many other ways also. So if anyone has any other solution, then you can share it. I will put it here. Okay, so I'm going to end the class here. I have last 9 minutes. This 9 minutes I'm going to cover that full outer join concept that uh, Abdifita asked in the beginning. I'll try to see what is alternate way to solve that problem. But before I end the class, I wanted to solve two more problems today. I'll try to give that two problems as assignments. Okay. Any questions before I give that assignment? Let me look at the questions. I have some questions here. Already covered. Can we use with clause in views? With clause in views, I think you can use with clause in views. If like data is huge and there are so many transformations, you can use any number of CT. I have in the real projects we would be writing queries where there are multiple CTEs. Okay, so I don't think so that's a problem. If there is really a requirement for that, then there is no problem. Okay. Okay, so let's come back to the assignment that I want to share with all of you today. Okay, so this is the assignment. I think this assignment is going to be a little too big. Okay, but you have the whole weekend to solve this assignment, so I think you guys can take your time. So, okay. The thing is, this assignment, okay, so just tell assignment queries starts here. Okay, because for this assignment, right, you need to use a new data set. Okay, so this is my fourth one. Okay, question number 4, and question number 4 or whatever. Okay, so this is my fourth one, and so the assignment number 4 is you need to find the popularity percentage for each user in Meta Facebook, and they have given you what is the popularity percentage definition. Okay, the thing is you need to use a different data set for that, and I'm going to share the data set of this query. The data set of this query is this one. Okay, I'll paste it here. So data set for okay, just data set. Okay, um, and this is the insert statement. That's it. Okay, so this is question number 4. I will give it to you and you guys read it, try to understand it yourself. Okay, and then try to solve it. Okay, I will not explain it here because I don't want to explain it the problem, because when you go or working on a real-time project or when you are going for interview, I will not be there to explain you what the problem is. You have to understand the problem and you have to solve it yourself. So try to solve it on the weekend. If you're not able to solve it, don't worry. I will try to solve it in the next session. Okay. This is the first question. And the second question is this one. So put everything in the notes section. Okay. So this is the question number 5. Okay. This is, I have taken this from Stata Scratch, but I would recommend don't go and search for this question in Stata Scratch, okay, and then get the solution from there. I want you guys to solve it yourself, okay. If you're not able to solve it, I will solve it yourself, and my solution may be different from what Stata Scratch might have used, okay. Um, so, okay, this is the question. Try to read the problem properly, okay, before answering this. And the data set is, okay, this data set is very, very big. Okay. So, but I will still paste the data set here. It's having, I think, 1,000 records or something. I don't know, some number of records. Okay. So this is the data set. Too many records. Okay, but that's fine. This table has, there are two tables in this particular query. Okay. Each table has, I think, 300 plus records. Okay. This is the insert statement. And okay, so can you guys solve these two problems? These two are actually real SQL interview problems asked in, I think, in the FANG company. Okay, I think it is from Google and Facebook. Probably these questions are okay. So you can be rest assured that these questions are very interesting. Let's see who can solve it. Okay. Uh, okay. Okay. So I think that's all for today. I'm going to copy this and I'm going to paste it in the session notes. So let me paste it in the session notes here. Today is 12, session 12. Okay. I hope this will not be too big a file because of this insert command. Should be fine. Okay, I will check the full auto join now. So I think that's all I had for today. Now I'll look at that problem from Abdi Fita and then we'll end the class. Okay. If anyone wants to leave, you can leave now also. But if anyone wants to see how to do full auto join in MySQL, actually even I don't know. I'm going to find it right now. Okay. So that's all. I will go back. I have taken this and what I will do is, okay, so let's go back to this problem from Abdi Fita. Okay, so this was, I think, from the painting data set. We had to find, display all the available paintings and all the available artists. If a painting was sold, then mark them as sold. And if more than one painting of an artist was sold, then display. Okay, fine. So, and how did I solve this problem? Where did it go? My solution was, what was my solution for this? This was my solution, right? So this is 12 records. And if you see my solution, I have got star for these two are the artists who sold multiple paintings. And wherever the painting was sold, I had another column sold. Okay. And my solution was 3, 6, 7, 8 lines long. And your solution is, okay, first of all, does this solution work? You're getting 20 records. How many records did I get? I got 12. So first of all, the data itself does not look correct. You're getting 20 records, and are these paintings repeated? The paintings are repeated, right? You have miracle here. Again, you have miracle here. Sunshine here, sunshine here. So the data is like duplicated. And you have Natali when 3 times. And again, Natal. So this query is wrong. Abdi Fita. So what are you actually doing in this query? So paintings left join with this again, left join with sales. Artist sales. Okay, so I'm not sure exactly what you are doing, but I think maybe you tried to use in left join. Oh, you're doing right join here. Then you did the left join. You wrote separate queries to do left join, then right join, and then put them everything together using our union all. Okay, okay. Let's do one thing. Let's try to solve this problem in MySQL. Okay. So first of all, let me open my MySQL. Where is MySQL? Okay. So let me open MySQL and let's connect to this. Let's open a new window here. Let's paste this. Okay. So first of all, does this query work here? It does not work. I think full outer join is the problem. Okay. So what is the alternate way of? I need to fetch all the paintings and all the artist, right? And then I need this. I think this part will work. Only this full outer join does not work. What is the error? So okay, full outer join. I think, yeah, full outer join is not supported in MySQL. Okay, so let's see how to do this. Okay, first of all, I'm going to again break this query. So this part I think I can do later. My problem is with this full outer join, right? And artist name. Okay, this artist name also I will print later. This one also I'll print later, and this one I will comment out. I'll do this. I'll include all of this once I have fixed this thing. Okay? So if I execute this, sorry, if I execute this, it's throwing an error. What is a better way of doing this is, so let me copy this first of all and put it here. If you are busy and you're not interested in looking at this, you can drop off. And if you're not using MySQL, you can drop off. If you're interested, then you can stay and let's see how I can solve this. Okay. So I have this full outer join does not work. Basically, I need every record from the left table and the right table. But okay, so this full outer join does not work, right? Okay. But left join will work. So left join should work, right? Why is left join not working? A dot ID equal to P dot artist ID. Oh, no database selected. Okay, first of all, let me select the database. Use sys. Okay. I'll remove this. Now I'll run this. Okay, so now I have got the. So now I have got. Okay, so now I have got this 8. So there are. Okay, I think this data set is not the correct data set. I need to use the new data set for joins. So first of all, let me use that new data set. Okay, 1 minute. Let me execute that. My data set is present here, here, joins. Okay, this is my joins data set. Come back here. So I will drop this. Okay, so all of this is executed. And I'll remove this and I'll remove this. Now I'll run the left join. Okay, so now there are how many? 1, 2, 3, 4, 5, 6, 7, 8. Okay, so there are 10 paintings. So this is fine. It is fetching all the paintings. Here I also want to print the a dot name as artist name, right? So I'll execute this. A dot name does not exist. Okay, what is the select star from artist? First name, last name. Okay, so I'll do this concat of first name and last name. Okay, and I'll execute this. Okay, so now I have got, so there are 10 paintings. I have got all the paintings and I have got the artist. But I also know that there are certain artists who are not present in this paintings table, right? So for that, I also need to now do one more thing. That is, I'll copy the same thing here. I'll paste it here. And instead of left join, I'll do a right join. And now I will execute this. And now I'll execute this. So now I have got all the artists, okay, and their corresponding painting. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Now if I do a union all here, union all, does this work? Okay, so 1, 2, 3. Did it work or no? So I did a left join. Okay, so first of all, let me understand this data in the table. Select star from paintings, artist. So I have 6 artists, Thomas, this one, okay. Then I have paintings, I have 10 paintings, okay, and their artist studies. So 1, 2, 3, 4, and then this two belongs to artist who does not exist here, okay. So okay, so first of all, let's do one thing. I'll go to PostgreSQL. When I just execute, okay, or when, let's do one thing. I'll just copy this query here. I'll go to PostgreSQL. I will put this here and I'll do a full join. I want to see how many records I get. So I'm getting 12 records. So basically I need to get 12 records here. So all this, all that. Okay, so but when I executed this, I think I only got 1, 2, 3, 4, 5, only 10 records. So how do I do this? So I got, oh, okay, okay. The problem is I put a semicolon here, so that did not get executed. Now I'll execute. Okay, now I'm getting the data. I'm getting too much of data, so I should not do union all. I should do union here. And now if I execute this, now 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so I think this is exactly the same as what I have got here. So if you look, 10 here, then 2 nulls. So I have for sunset and sea predator. Okay, so I think that's all, Abdifita. What you need to do is you need to use this query. Okay, so I'll show you how to do that. So what you can do is, okay, so I will put this entire thing into a, I can put it into a subquery or I can just create a with clause. I'll just tell with CT as this one. Okay, and I'll move this to the right. Okay, and my query was till here I have already taken, so I need to take this. So select from CTE, and then I do a left join with whatever I was doing previously, and then my select clause is going to be this whole thing. So select this whole thing, right? I think that's all. Probably this should work. Let's see. I'm getting an error. What is error? Mm, unknown command p dot name. Where is p dot name? Oh, okay, okay. So I'm using CT here. So my CT has, I've already got the name here and I've got the artist name here. So I'm joining s dot painting ID equal to p dot ID. So p dot id, okay, so I will fetch some columns here, p dot id, okay, and I'll say p dot id. Okay, that's the first thing. Then I also need a.id, right? So I also need a.id, okay, and here a.id, okay, and I think now it should be fine. So I can, instead of doing p dot, this p.id, I will name it like painting id, okay, as painting id, and this will be as artist id, okay. So I'll just copy this whole thing and put it here, okay, and then I can just tell cte dot painting id, and here I'll just tell cte dot artist id. So I think this join will work, this join will work, this should work, but here p dot name will not work, but I need to say painting names because I have already done that, and then here I need to do the concat of artist name. So here I can just tell cte dot artist name comma this one, and here is this one. Okay, I think this query should probably work now. Okay, so if I execute this, okay, so now you can see that this output is using this query is exactly same what I got from here. So instead of full outer join, I use the combination of all this. Okay, Abdifita, did you understand? I Okay, so you already got it. So I'm just going to copy this. If anyone, because this same method will work everywhere, even in PostgreSQL also I can use the same method. So I'm just going to say here, and I'll execute this. You can see that it's working fine here. So what I'm going to do is, in my notes file, I'm going to add this. Okay, if anyone wants an alternate method for that, so this one I'll add in the very beginning. Okay, so solution 2 for query number 4 from previous session 11. Okay, replacing full join with left, right, and union. Okay, so in the notes file that you will be getting today, right, you will get the solution here. Okay, this one. Okay, yeah. Okay, so I think that's all. Any questions that you have? Did you guys understand how to solve a problem replacing full join with left, right, and union? Okay, so is there anyone still left? Okay, we have still 29 people and we are past that time. I hope today's class was useful. You learned something interesting, and the two assignments that I have given are slightly tricky. Okay, try to solve it on your own, and let's see who can come up with a solution. Okay, if you come up with a solution, you can share it with me in the Telegram group, and uh, I'll try to have a look. Okay. Okay, so that's all. I'm going to share this notes file, and so yeah, okay. So thank you so much. Bye. Have a good weekend. Thank you. You too.